Okay, mic check 2. Can you guys hear me today? I've kind of I pulled everything out of here and put it back, plugged it all back in again. So it's always a bit skeptical when you do that. Does it all connect up back how it should? Awesome stuff. Good stuff. When something's working, I hate touching it. Like, the stream's been working quite well the last couple of weeks, mostly, and I had to actually move the PC for the last week. I had to take it upstairs, and so I had to unplug everything. And usually when I unplug everything and then I bring it back and I put it exactly as it was, something doesn't work, but it seems to be alright at the moment. Greetings guys, thank you very much for tuning in. Oh, for goodness sake. Now, we're looking at the Rockford. We're looking at the Rockford BD 1500.1. Nice, beautiful old school amplifier, and I've been working on this over the last couple of weeks. It's not been insanely complicated. It's just taken a little bit of time because every time I work on it, I find something else that I need to order. So, and the things that I've ordered have taken like a fair few days to come. So yeah, the reason that this is taking a long time is just because I keep finding new things to order. So we're going to hopefully try and finish this one off today. I hope that all the parts that I've ordered are everything that it needs and it doesn't need anything else. I'm just going to try to, I'm just soldering the remote cable on there, because this amplifier, the remote cable is just a tiny little, it's just a little thing here. This is the remote, so I'm just going to solder that on there for a moment, just while I work on the amplifier. And I also need to go and find my multimeter, because I've been doing a lot of other things the past week, which is why I haven't been streaming. I've been doing some other work, and my multimeter is no longer in the workshop, so just bear with me. I need to go and find where I'll put that. There we go, found it. It was in the car. Alright. Cool, so we've got Germany going on. We've got, well, yeah, India. Hi, how's it going? Hopefully one day you get an amp with a noise issue. With a noise issue, like a crackling noise or... Had two of these. One of them blew up 3 times on low power. The other one came in non-working condition. Have it repaired, then all of a sudden died again in smoke. There's a lot that can go wrong on these amplifiers. They are lovely amplifiers, and they're not too difficult to repair, but you just need to know what to look for. This is actually my first time repairing one of these, so I just need to make a quick repair to my. Yeah, you can see here that my really cheap ass multimeter test leads, they just keep snapping, and I keep repairing them and they keep snapping and I keep repairing and keep snapping, so I just need to go and get some glue to fix that before I start. Okay, let's just quickly glue this on and we'll be good to go. I have an amp that when turned off it sounds like an old TV. How does an old TV... I can't remember how the old TVs sound when you shut them off. Like a popping sound, or like the static on the screen? How do you mean? Okay. So this Rockford that I'm working on hasn't actually been too complicated. Like I say, it's not really giving me too many headaches. The only reason it's taking so long to repair is because I keep finding new things wrong with it, and then having to order parts that then take a little while to arrive. So yeah, we've been quite easily finding the faults with this. Something fell on the board there, but what was it? Piece of wire. But yeah, so I just had to order a few new parts for this. And so the most recent parts for this amplifier, if you were following the repair log for this Rockford amplifier, if we take a look in the output section over here, this is the output drive circuit over here, right? I'm just going to use my my oscilloscope probe as a pointer. We've got some voltage regulators here. These are the drivers for the output, the MOSFETs on the output section, okay? And just before the drivers, there appears to be an optocoupler per side. We have like two sides. This is it's actually a full bridge amplifier. It works in quite a similar way to the Brazilian amplifiers, tar amps and stuff like that. Pretty cool. So yeah, the full bridge amplifier, and one half of the bridge is driven over here, this side, and we have the driver. And then we have an optocoupler which feeds the driver, which isolates the drive circuit output side from the rest of the amplifier circuitry. And we've got another one over here, which is for the other side. And I noticed that we had drive on this driver over here, but this driver wasn't getting any square waves. It wasn't actually receiving any drive whatsoever. And I believe I traced that back to a faulty optocoupler, and we removed the optocouplers from the circuit, and one of them read differently on the multimeter between some of the pins. So I believe that we had a faulty optocoupler. So I decided to go ahead and just replace both of them anyway, seeing as they're pretty cheap. Hey, your mic picks up low noises. Can you filter them? I want to listen to music at the same time. Do you mean my mic picks up low frequencies? Like bass frequencies? Because when a bus goes past outside, it's like, wow, you get this this really loud bass. It's not particularly common though. So it's only like once every sort of half hour, maybe not even that. So we've got ourselves a couple of new optocouplers here. And these are A2211. This is the optocoupler. So I'm going to focus on that. These cameras do have good macro when they decide to autofocus. Come on. It will focus eventually. It will focus. And it does look quite nice when it focuses. Actually, I think I turned autofocus off on that one. Let me see if I can turn the autofocus back on. Front Logitech. And then configure video. Ah, I turned autofocus off. That's my fault. Okay, let's see if it works now. There we go. A2211. And these are the optocouplers that this amplifier uses. So first of all, I'm going to just drop these bad boys in and see if she comes to life. Because the only thing that we were missing from this amplifier was the drive on this second driver over here. So if by replacing these two optocouplers, the drive appears on the board, then I think we're safe to fit all the MOSFETs back in place. You can see that I removed all the FETs from this amplifier board. The row of FETs is actually here. Now this amplifier, when it stopped working, the FETs didn't actually blow. There were no blown FETs, either no blown power supply FETs, no blown output FETs either. It just wasn't creating a Class D switch wave. So because nothing was blown, none of the FETs were blown, I didn't want to be repairing it and for either my probe to slip or for me to make a mistake or something to blow the FETs whilst I was working on it, because then that makes more work for myself. So I decided to desolder the entire output MOSFET heat spreader board here. And by that means I can then probe the board and check for the drive waves with the FETs off of the board, so I don't risk damaging them, because removing these things, they're all soldered onto this heat spreader board, and it takes a bit of time getting them off, and it's not something that I'd like to do if I can avoid it. So since they weren't actually blown from the start, I thought let's remove them just in case, and let's work on the board with them out. So just going to pop these two just going to solder these two in quickly, and we're going to have a look to see whether this solves our issue or with having no drive on one of these banks of outputs, one of these drivers. Okay, so that's pretty simple. Just two new optocouplers fitted. And now what I'm going to do is power this baby up and see whether it's made a difference. What we were missing before is we were missing drive on this driver here. This wasn't being fed with any square waves whatsoever. So let's plug my power supply back in. A few people have said to me that with this amplifier, you can actually run the thing with only the remote signal and ground, and it doesn't build the full rail voltage. So I'm going to try that just out of pure interest, because that would save me having to discharge the thing all the time, because these capacitors don't discharge very quickly. I'm just going to remind myself which one is positive, which one is negative. That'll be this one is positive, so let's load this one up with, let's load the other one up with the ground first. I'm going to try that method of just having remote and ground. This Rockford's have BD sync cables, so two of them can be bridged together. But if they work almost like Brazilian for rail, how is that incorporated? Good question. I don't know how that circuit works exactly, but what I do know is that this amplifier works by producing, it puts the half rail voltage on both positive speaker and speaker plus and speaker negative, and then both positive and negative speaker output terminals, I believe, should have the audio signal on them. We will see that for sure when this is up and running. As far as I've seen, I've never seen any full bridge amplifiers like that that have ever been bridgeable or strappable because they're already full bridge. So I don't quite understand how that would work. But I've not yet had one of these in the workshop in a working condition, so fingers crossed we'll get this one up and running and we can see exactly how it works and what the jam is there. Cool. Alright then. Okay, 11 volts on the power supply. I've changed my camera angle a little bit and you can't see the power supply anymore, which is slightly annoying. But okay. So let's go back to our output section here. And the two drivers that we're looking for square waves on are these two here. So if I leave the positive from the power supply out, I'm not going to plug the positive into the board. I'm just going to have remote and ground, because apparently that is we can check the drive waves like so. So if I turn it on and see what happens here. Okay, yeah, it appears that we do have some drive waves. You can see here. So this is with just the remote connected, and no, just the remote and no positive. So we get drive waves on the power supply section, but do we get any drive waves on the output section without the positive connected up? So we had a drive wave, I think it was over here before. Okay, no, it doesn't. We don't seem to have any drive waves on the output section. I think we need the positive. I think we need the positive speaker. Sorry, the positive power in the board for the output section to start oscillating. So that's interesting to know, though. If you're ever just doing a power supply repair on this board, you can leave the positive out, and you can check the drive waves just by running the remote and ground. But if you're working on the output section, then it doesn't look like you can do that. Have you ever went through the repair manual for Perry Babin? If so, what are your thoughts? Yeah, Perry's repair guide is actually what taught me most of what I know. I bought Perry's repair guide probably about a year ago now. I spent weeks and weeks and weeks reading it, learning it, reading it, and then I put a lot of his teachings into practice. You know, I started trying out amplifier repair for myself. I went ahead and bought some blown amplifiers from the used market, and yeah, just use them to learn on, basically. Use them to try and repair and to put Perry's teachings into practice. And yeah, absolutely phenomenal guide. It's the guide that I recommend everybody purchase who's looking to get started with amplifier repair. I think it's a really, really fantastic source of information, and it's really well laid out, and there's gigabytes and gigabytes and gigabytes worth of info. What's your temperature on your soldering iron? Well, it's an AOUA soldering station, so I don't think the temperature is particularly accurate, but I usually run it anywhere between 330 degrees Celsius and 400 degrees Celsius, and that's on my standard wedge tip. On the small pointy tip, usually it's a bit lower, because usually with the small pointy tip I'm soldering much more delicate pads and areas, so and because there's much less thermal mass, you don't need it quite as high. So usually between 300 and 400, depending on the size tip that I'm using. Maybe if you can have a video specific to oscilloscope settings. Yeah, maybe, but every oscilloscope is different, so it wouldn't be relevant to a lot of people. Like, I could go through all the settings on my scope, but they might not be the same or the optimal settings for a lot of other people's scopes. When you get your scope, you just need to take like a good bit of time playing with it and getting used to it and seeing what all the buttons do and what all the functions do. That way you then get a better understanding of how your scope works and what sort of settings it likes to be on when you're testing different points on the board. I could tell you some settings that I use for the boards that I work on, but with your scope it might not be optimal. Okay, so yeah, back to the repair. The power supply now, I've connected the positive up, so the output section will load up. So let's try this again. Let's see if our waves appear where they should on the output section now. I'm going to turn my scope up to 50 volts so I can see the output rail build. And I'm going to allow about 2 amps to pass. Okay, I'm just going to take my thermal imager just to ensure that nothing is getting crazy hot on this board. Okay, let's have a quick look. Power supply section looks good, nothing's getting hot there. Output section, yep, stuff's staying pretty cold over here as well, which is nice to see. The amp was drawing about 1.8 or 1.9 amps on idle, which is not too bad. So let's power this up again. We've got 2 amps. Yeah, 1.9 amps this is drawing. So what we're doing is we're looking for square waves on these drivers. Now, from last time, I think, here we go, starting to appear perhaps. Yeah, there we go. So if I zoom in a little bit here, so we've got a slightly interesting looking square wave there. And how about this driver over here that we had nothing before? Now this driver has some much bigger square waves on it than the other one. It's interesting, but I think that's correct. I think the what do you call it? Duty cycle is actually inverted between these two sides. So what I'm going to do, I think I remember last time I fed this amplifier with some 40 Hertz input, and that allowed me to see the square waves nice and clean on the drivers. So I'm actually quite pleased to see that we do have a drive signal now on this driver that we didn't have before. So replacing the optocoupler does seem to have changed something. Now I need to remind myself which one of these is the audio input. I don't think this amplifier was sent to me by another technician, and I think that he forgot to include the end plate for that. So I'm just going to quickly go to Google and check which one is input. Rockford BD 1500.1. So I think, here we go, the input is, and this actually does, input is, it looks to be the top two. So the inputs are the top two. Cool. Alright then. So if we pop those in there, turn my turn this on, turn my frequency generator on. My frequency generator is just on top of my scope here, and I'm going to play a 45 Hertz, I think. Let's go down. Well, maybe I'll probably play 50 Hertz. Why not? I'll play 50 Hertz. And amplitude down on lowest. And now I'm just going to change my scope settings so I can see a 50 Hertz, because I'm zoomed in quite far at the minute. Okay, that should allow me to see a 50 Hertz. And I think the gain on this amplifier, where's the gain on that? I can't remember where the gain is either now. Gain is this one, which is directly next to the. Okay, so that's down on lowest. And we've got phase and subsonic filter. So let's keep that to the off position. Okay, looks good to me. Hi Tom, I had to move, so I haven't been on chat lately. No, that's cool, no worries. Okay, so now we've got 50 Hertz going into amplifier. Let's power it up again and see if the drive waves look any different. I need to reject high frequency on my scope. Okay, drive waves should appear some point soon, I imagine. Let's have a look. Okay, so we've got some noisy ass looking waves here. If I AC couple my scope so I can actually zoom in on that wave, goodness me, that looks like a lot of noise. Right, so that okay, that's what we've got over here. On the gates, now on the gates, what do we have on the gates? Okay, this is what we have on the gates. So, okay, right, cool. So that's on the gates of the MOSFET pads, right? Okay. How about this side over here? Didn't have anything on it before at all. So on this side we now have something that looks like this, which we didn't have before. We had absolutely nothing on this side before. So the duty cycle of that looks like it's the opposite duty cycle to that. So this one has a shit ton more noise on it than the other one, though. I'm wondering where that noise is coming from and if that's an issue. That's very, very noisy square wave. Ooh, something smells hot. Something smells very hot on the board. So I'm just going to take my my thingy here and see what's getting hot. Something smells a bit warm on there. Okay, so the things that are getting warm on the board are, we've got a rail voltage, what looks like a pull down resistor. So there's a large resistor here, and I think that is designed to get very hot. That's what they do. They're dropping a lot of voltage across them, so that's not a problem. Other things that are getting hot, we seem to have, let's see, nothing else is getting crazy hot, like dangerously hot. Everything's sort of generally around the 25-degree mark. That's perfectly acceptable. The optocouplers no longer getting warm. The drivers are no longer getting warm. They were before. One voltage regulator here is getting a little warmer than the rest of them, but nothing excessive. Okay. I just wanted to because I can obviously smell that resistor. The resistor's kind of old, so they do smell a bit when they heat up with it. And the board itself has been in the workshop, so the board was pretty cold for a start. So that's fine. Now what I'm going to do is take my other probe for my oscilloscope. So I'm going to put this on 2-channel mode. If I can find whether, there we go. So I'm going to turn the second channel of my scope on, and I'm going to probe both of these gates on both of these sides of this amplifier, so we can see the duty cycle of both of these and make sure that it matches up. I believe that this, by the looks of it, this thing needs to work by having opposite duty cycle on each side of the outputs. So if I go to my scope and I turn channel 2 on, and I set the settings up for the same thing on channel 2 with AC coupling. Okay. Now if I turn it on again, we should see when the output waves build here. It takes a couple of seconds for it to kick in. Here we go. Yeah. So if we turn 2 off, you can see we've got the duty cycle of 1 and the duty cycle of 2 there. And they appear to be perfectly like out of phase of each other, and they're filling in the gaps of each other. So without knowing this amplifier and how it's meant to work, that looks to me like it's kind of doing the right sort of thing for how this should work. Perry has made a very extensive guide on this amplifier repair, actually. So maybe why don't we have a quick look and see what Perry's guide says on this amplifier. See if there's anything we can take from his guide. So I think if I go to what was it, BD 1500, BD 1500. I need to open my amplifier repair guide again. 1 second. Where is it gone? And then if I go to, so let me just try and show you this. Webs. Okay, so this is Perry's guide. This is what you'll get when you pay for his repair guide, and the amount of information is absolutely incredible. So I'm going to go ahead and see whether I can find his repair notes on the Rockford that I'm currently looking at, because he has done some very good repair notes on this amplifier. I think it's the, let's have a look, where is it? Repair notes 500, older repair notes. He definitely has done one on this exact amplifier. I don't think the link is here. I've got to try and find where the link is to it. Perhaps it's this one. Here we go. This looks like this looks like it. Yeah, here we go. This looks like the one. Okay. Here he talks about how you can power the power supply drive up without the B+ connected, which is what we discovered earlier. Now I'm just going to see whether... okay, here we go. So this is the A2211 I just replaced, and we already replaced the LM6171 before. That's fine. Trouble in the audio stage. The most common failure is in the audio circuit is blown output transistors. We didn't have that. That was actually not the issue that we had here. While the voltage on pin 7 of U21, that's not in this picture, the output pin is high, etc, etc. Let's see if we can talk about any of these ones that we've replaced. The following flash file shows the IC U11 that's used to generate the square wave, and from that the triangle waveform. The triangle waveform is essential for Class D operation. The triangle waveform is what listens to the audio signal coming in, and it's what converts that into pulses for the Class D section. It produces a square wave at its output. The other op amp produces a triangle carrier wave. If this op amp has the proper power supply voltage, it should oscillate. If the oscillator does not operate, even though both the positive and negative power supply voltages are present, the op amp is likely defective. If there is excessive DC offset on either pin 1 or 7, the op amp is likely defective. This isn't an extremely common failure, but it happens. So let's go ahead and check that then. That is the LM6172. That's the surface mount, and that is U11 by the looks of it. So if I go and have a look at U11 on my board here, so I think that should be U11. Where are you? Not U21. Ah, there we are. There she is. It's the one that's deep in here. So if I put that there and zoom in. So that's U11. So if we compare that to what we've got on here, we can see the different waveforms that should be present on each of these pins. So firstly, let's look at pin number 1. So pin number 1 is always directly underneath the dot. So if I find that on the board here, that should be right next to C44. Okay, yep, that's pin number 1 there. So pin number 1 should have this square wave on it, which is reference 5 volts. So if I turn channel 2 on my scope off, and we should see a square wave there. Let's see if we do. Yeah, looks good to me. Yeah. Okay, so that's we're seeing what we should on pin number 1. That's a good start. Let's check pin number 2. Pin number 2 is the one next to it, and we should have, I think that should be nothing perhaps. Doesn't seem anything on there, so let's skip and let's check pin number 3. We should have this kind of funky looking kind of triangle-y, squarey cross between the two wave. So that's pin number 3. So let's go ahead and check that. There we go. Yep, that's present. Perfect. And let's check pin number 4. We should have negative power supply, which we're going to have if this thing is doing the thing it's doing anyway. Pin 5, it should be flat. Pin 6 should be flat. Pin 7 should be the triangle wave. So I'm just going to check that the triangle wave looks good. That's the next most important thing. I need to go back to, yeah, so sorry, pin 7, triangle wave. So let's check the triangle wave looks good. Yep, looks good to me. All right, wicked. So we know that that's working. So let's now scoot on down a little bit on the page and see if he gives us any pictures of what the drive waves should look like on the gates of the outputs. See, this is really interesting. He does a really big section on this, but this is basically how the Class D drive, or the PWM generation circuit section of the amplifier, generates the pulses for the output section, but referenced to the sine wave. So you can see here when the sine wave is a peak here, that turns it then into a large square, a positive square bit there, and then as it's coming down, you can see that there's like a, because it's like halfway in between, you get like a small pulse up, and then when it's at the bottom, you get the large large square at the bottom. So you end up with like large, small, down, small, large, small, down, small, etc. That's how it references the audio signal, and it uses the triangle wave to pick out where the peaks and the smaller parts of the sine wave are to build up the. This is the worst explanation of Class D ever, so I'm going to give up with that. I know what I'm trying to say in my head, but it's not coming out in words. But Perry's guide does it a lot better than I can. Okay, let's move on a little bit. So we know that the triangle carrier is all good. Here we go. Now we've got some waves that we should have present on the optocouplers. Now I think we're probably going to be alright at this point because we have drive waves on the gates of the MOSFET pads. So I'm going to see whether he's done. Here we go. What's this? On the input of the 4420, the input will be nearer the negative 10 volt regulated. Yeah, that's what I saw earlier actually. That's why I put my scope checking the PWM signal. Okay, so this is perhaps why the Rockford is in fact bridgeable. It's not exactly the same as the Brazilian style full bridge amplifiers. You've got a separate bank of rail switches. Oh no, hang on a minute. That is how it works. It's very similar. Yeah, no, it is very similar to Because if you've got in Class D amplifiers, not every single one of the FETs produces output unless you are using P channel and N channel MOSFETs. Yeah, only some of them will produce the output. I think it's the low side ones that produce the output, and the high side are just rail switches. So that might be what's going on here. With high voltage, when high voltage is disconnected, the drive signals for the two groups will look the same. With the high voltage connected,
When high voltage or any significant voltage is applied to the higher voltage wires, there will be significant spiking or ringing on the drains of the collectors. That'll make the output switching appears to have a noisier drive signal. That's perhaps what we were looking at earlier, so that might be actually okay. In the next two photos, you'll see where the gate drive signal for the switching FETs. Okay, yep. Optocoupler signals. I just want to see whether he's given me any pictures of what we should have on. Ah, here we go. These are the rail switching transistors. So with no input signal, this is how it should look with the FETs mounted. Amp being driven into a 4 ohm load, 20 volts AC, 80 Hertz. And that's how it should look when that's happening. Audio switching transistors should look like this. So we haven't got any FETs in the board at the moment. So the signals will look very different to how they would when we have FETs in. So this is actually a fucking brilliant guide. He's literally given you what all of the waves should look like on every single pin of pretty much every single IC on this amplifier output section. So yeah, this page, this guide will literally get you up and running with these amplifiers, whether you like it or not. No matter how much of a headache they seem to be, this will sort your eyes out. Okay. I'm pretty confident that, looking at that, I'm pretty confident that actually we may have a successful repair on our hands. So what I'm going to go ahead and do now is, because Perry didn't do any tests of the drive signal with the FETs out of the board, they were always in the board. And so what I'm going to do next is I'm going to fit the MOSFETs back in place on this board and see if the thing comes to life. But before I do that, I need to discharge the rail capacitors, because the rail caps on this amplifier don't discharge by themselves. So if I go ahead and try and solder these FETs in place, then it's possibly going to blow them or spark the fuck out of my soldering iron. So let's discharge the caps first. Will you bench this one at 4 ohms and 2 ohms? Sure, yeah. I bench all the amplifiers I repair. I don't always do 2 ohm and 4 ohm, but if people want to see what this does at 2 ohm and 4 ohm, yeah, well, okay, we'll do that. So let's just discharge these. Okay, here we go. Oops. Sam, can you? I can't link you the guide, because you have to pay for the guide. You have to buy it from Perry. So the page that I'm looking at here, okay, this amplifier repair guide page is not actually a website. You can see in the title here, it's on my C drive. C users, documents, etc. So it's actually a local file. It's not on the web. You have to buy the amplifier repair guide and download it to your PC, and then you can use it. Are there any notes on the MTX 1501D in there? Most likely, yeah. He's done notes on most. I mean, I'm not gonna lie, the guide is a little bit out of date. So yeah, lots of modern amplifiers on in there. And I don't think he hasn't updated it for quite a while, but amplifier design hasn't really changed much at all in the last 10 or even 15 years. It's pretty much mostly very similar, the same with small refinements made. So all of the information in Perry's guide is still completely relevant to amplifiers you'll be working on today, especially old school stuff. Lots of good info on old school stuff on it. Now I've got a little bag somewhere that's got all the screws for this amplifier in. Right, can't remember where I put it, so I'm just gonna. So yeah, I'm just gonna load this back up. Make sure there's no voltage sitting on any of these pads. Just before I touch my soldering iron, I want to make sure there's no high voltage that's left anywhere in any capacitors that I've missed. No, I think we're okay. A little bit of a bump on one of them, but oh, I have it. Just want to know where you found it. Basically, a lot of the this is the slightly annoying thing about Perry's guide. The only criticism that I'll give Perry's guide is that sometimes it's very hard to find the notes on the different amplifiers. Some of his repair guides on certain amplifiers won't be linked anywhere in the normal sort of progression, the index. They're in the files that you download, but in order to find it, you have to actually do a local search on your file system, on your computers. You have to go to Windows Explorer, and you have to go to the into the folder where all the files are, and then search in Windows Explorer for Rockford or BD 1500.1 or whatever, and then look for the HTML file that is regarding that repair. That's the only slightly annoying thing that I find about his guide, is that not all of his repair notes and guides on certain amplifiers are actually listed or linked in the main flow of the repair guide. You have to actually search for the individual HTML files for that section of the guide. Okay, so yeah, I desoldered all of these with it still on this heat spreader, so I've just got to line up all the legs, and there's literally probably like a good 60 or so legs I've got to line up with these holes and solder them back in. Seems to be going a little bit easier than I thought, which is nice. Okay, all right. Seems to have gone quite nicely, actually. Cool. I think all of the legs are all through the holes. Yeah. Okay. What do we reckon, then, you guys? What do we reckon? Do you reckon this thing's going to work? Do you think those drive waves were looking like they should have been looking? Mount the PCB in the enclosure and solder a few from the top to align it. I think luckily when I desoldered this, some of the solder on the legs stayed at halfway up the leg where it was attached to the top of the board. So when I removed it, there were like these little mounds where the height was perfectly as it was before. So I think we should be alright. And there's quite a lot of excess anyway on these legs that they'll bend perfectly into place. I think we'll be fine. I reckon that noise may cause you to second guess yourself at least once. Yeah, the noise was unexpected, but after reading that section on Perry's guide where he mentions about how that section has noise on the gates and the source, that's kind of put my mind at rest. Okay, and as always, I'm just going to go ahead and make sure there aren't any solder bridges between these connections. Something you just need to get into the habit of doing every time you finish soldering something where there's legs. Well, anything at all really, but... Has anybody managed to give the cheap clipping detector method? Has anybody managed to give that a go yet? I'd love to hear how you guys found it. I've been using it for the last 2 or 3 weeks. That method on a whole variety of different systems. When someone comes around and just want to check their gain points, want to check their clipping points. In addition to having the scope hooked up, I've been using that to see how it works and see how it compares to different systems and different power levels and stuff, and it works absolutely perfectly. It's wonderful. It's so simple. A lot of the time now I don't even bother taking the scope out. I can hear some bass sounds like someone's banging songs in the background. Yeah, that's just buses and trucks that go past outside my house. They build up a low frequency sine wave in the workshop. It's to do with the engine frequency and the distance from my workshop to the road. It builds up a perfect sine wave, which is kind of cool and slightly annoying at the same time. Alright, so moment of truth then. I'm just going to check there's no short circuits between these legs. And then we shall fire her up and see what happens. See if it comes to life or see if it comes to smoke. Cool, no shorted legs. Let's turn our power supply on, get our scope probes, crank up to 50. Turn my thermal imager on so I can see, make sure nothing gets hot. Alright, let's see what we have going on. Aha! It's drawing 3.2 amps. We have a nice square wave on this side of the board. Let's check this side of the board over here. We also have a nice square wave over this side of the board. So it is drawing it's drawing 3.2 amps, which is quite a lot for this amplifier of this small size. I'm just going to make sure that none of the FETs are getting singularly warm, or none of the drivers are getting singularly warm either. No, it looks okay to me. Doesn't seem to be getting warm. So I'm going to put this away. And I've only just given it a couple of seconds of operation then, so I'm just going to plug my frequency generator back into the board and make sure that there is audio signal on the speaker outputs of this. So if I turn my scope back to the low frequency setting and turn that down to there. Okay, 50 Hertz. Get my probes. Cool. There's some audio signal there. And interestingly, how about the other one? Okay, no, so it does only output audio onto the positive speaker output, which will make these things bridgeable. Cool. Very nice. Muy bien. So we potentially have a successful repair. The thing's alive, and yeah. Awesome. Very good. Very nice. I'm happy that that works. Obviously, to ensure that this thing works correctly going forward and doesn't keep blowing, I'll need to mount this back into the heatsink and do some endurance testing with it. Before I do that, I need to obviously put it back together, and I need to, the drivers you can see on here, if I shimmy this over a little bit, you can see that the new drivers that I fitted, which are here, I haven't put the heat sinks on yet, so I need to find my bag of goodies for this amplifier, the screws and stuff, and put those back on before I put it back in the case, because otherwise they'll overheat. But yeah, cool. We made it work. Should be around 1.8. 3.2 amps is what mine draws. I thought I was wrong. Yeah, if anyone knows roughly what the idle current draw for these amps should be, let me know. I think it was 3. Let me check that again. Let me check what it's drawing. Yeah, 3.2, pretty stable at 3.2. It's doing all the right things though, all the waves are looking like they should. 3.2 amps does suggest that there's power being sunk somewhere. If it's sinking 3.2 amps somewhere, then something must be getting a little warm somewhere. Well, that doesn't really seem to be. Can you hear that bass? There it is. There's the bus outside. Bwab. I'm going to let all these FETs cool down because they're still warm from soldering. Once they're cool, I'm going to turn it back on again and see if they get warm pretty quick. Because I haven't had any ones of these in the workshop before that are fully functional, I don't know how warm the FETs should run when the thing is idle. I am only giving the amplifier 10.5 amps, 10.5 volts. So if I boost that up to 12 volts, or maybe even 13 volts, because giving it higher voltage should present any potential issues with the amplifier quicker. So let's give it 13.3. So I'm going to give it 13.3. I'm just going to wait for the those FETs to cool down from soldering, and then I'm going to power it up again and see if anything explodes or it gets hot. The resistors, Sam changed them. Which resistors, buddy? What, the gate resistors? I didn't read any resistors that were out of tolerance, but I'll go through them again. Oh, you mean the large resistors, the great big fuck off big ones that were getting really hot. Okay, maybe I'll change that. Because there is a very large resistor on here that was getting pretty hot and looks a little bit janky. Look, if I zoom in here, there's a resistor here. I just assumed it was a rail voltage pull down resistor. Right there, this thing, R44. Looks a little janky, and it gets pretty hot. So perhaps I'll change that because it looks a little bit rusted. Yeah, I think I should probably change that. What's that meant to be value-wise? Oh, I can't quite see it at that angle. It's meant to be a brown, black, gold, perhaps. It's quite difficult to see because the resistor is obviously very, very old, and the colours, especially when the resistor's been running very hot, the coloured stripes, they discolour a little bit. It's quite hard to see what it is. I think it's a brown, black, gold. I can never remember these off the top of my head. I think it's going to be like black is 10 with like lots of ones and zeros. So it's going to be like, what is it? Apparently it should be a 10 ohm. If I've read it correctly, it should be like a 10 ohm. If the colours haven't discoloured too much. So what does it actually read? If I go to the bottom of the board here, where is that? That's this one here. Yeah. Flip her over. So it's measuring. Looks like it's measuring 12 ohms. Yeah, it's measuring exactly 12 ohms. And the 2 ohms difference wouldn't make any difference on that one. Amps run a little warm if the bias is high. Yeah, this is a Class D though. It doesn't, from what I understand, this circuit design doesn't have any biasing that you can do. I think that's only for Class AB.
Alright, let's see if that's cooled down, and then we can turn it on again. Okay, so that's cooled down to a fair amount. I'm just going to lock in the temperature of that as it stands, so I can use that as a reference point. So the current temperature then of these FETs is looking like 20.6 degrees Celsius, and the same over here by the looks of it. Yeah, about 20.2 to 20.6 degrees. So let's turn her on, let her idle for a minute. I've bumped up the input voltage to 13.3 volts, so there's a little bit more voltage in this now. And we have switching. It's now drawing 3.8 amps with 13.3 volts worth of input. It's drawing 3.8 amps. Is it running 100 kilohertz? It will draw more current due to switching not under load. Ah, it's running 87. It's running 87 kilohertz. So that was on for about 10 seconds. Let's see. Have they heated up at all? Ooh, yes, they have. They have heated up. So the FETs are now running at 25 degrees Celsius. Or should I say the heat spreader is running at 25 because they're so well heat sinked. So yeah, we've got it is a pretty high switching frequency, I think. Well, no, it's not that high. 87 is not that high actually for an output section. No, it's not that high. This resistor is not getting that hot anymore. It's only getting to 25 degrees as well. So the hottest thing on the board is, I mean, the hottest thing on the board is 25 degrees. Nothing else on the board is hotter in the least. I'm going to leave her on for a bit longer. So the FETs are slowly climbing to 30 degrees. Yeah, we've got 30 degrees on the FETs now. And on this resistor, on this 12 ohm resistor, we've got 55 degrees Celsius. And wow, one of these voltage regulators is really getting quite hot indeed. Okay. So these voltage regulators here in the middle are getting to 40 degrees, which is these two here. But because they're voltage regulators, they will be dropping voltage, so they will run warm. I'm wondering if this is just how this is meant to work. Nothing's getting like stupidly hot. 50 degrees for this resistor is fine. 30 degrees for the FETs is fine. Voltage regulators, 30 degrees is fine. Between 30 and 40 degrees is okay. I need to put the heat spreader on the drivers. Yeah. Maybe it's fine. I'm going to go ahead and say that it's probably fine, and I guess we'll find out during the endurance test when we apply load to it. So let's flip her over and discharge the caps, and I won't reassemble this on camera because that's boring as fuck, so we're going to move on to something else, and I'll do the endurance test later and the bench test later.
discharge spark. Okay, so let's move on to the next amplifier. I just bought the Quick 861 DW. It's an awesome hot air station. Cool. Good stuff, man. Okay, cool. So we shall test you later, my friend. Okay, what have we got next then? Let's have a look. I think we should get started with this one. This is a Ground Zero, I think this is the nuclear range 4K. Now this is actually the exact same amplifier that I repaired on my first ever amplifier repair video. If you guys remember, the first ever video that I put up on amplifier repair was talking about how these amps work, and I'm pretty sure that it was these amplifiers that I went through and repaired. This amplifier, yeah. Pretty sure it was. Have you ever burned an amp by mistake, or like one that's gone up in flames? Like, yeah, of course, absolutely. When you're learning amplifier repair, yeah, obviously mistakes happen. And the first ever couple amps I tried to repair, this was like long before I ever did any videos. You know, this was when I was literally just tried repairing an amplifier for the first time. I didn't use a small power supply to power it up afterwards. It was a Hyphonics 16 some Brutus 1600 or something. Yeah, I replaced a bunch of parts, and a friend was helping me through text. He was like saying, yeah, change this. I probably left a solder bridge somewhere. I probably fucked up something, and the second I plugged turned the supply on and touched the remote, the second I touched the remote, the whole thing exploded in flames with bits of FET flying around the room and like smoke, and it was crazy. I think that whole kind of massive explosion thing, I think that's only happened. I think that's only happened one time. I've had amplifiers before where the power supply is smoked up during the endurance test, but that's always a good thing because it means that I can then see what it was that caused that. Because sometimes when you're doing an amplifier repair, some things may have been damaged that are completely invisible. The issues with them are impossible to see until you run some power to it. So as long as all the issues present themselves to me whilst it's in the workshop and I can fix them, then it's no problem at all. But generally these days things don't explode much. With the low current supply and with the amount of precautions that I take, don't generally get things exploding. I think the only things that go pop are really big amplifiers where you've got like one FET that's slightly bad, and because it's got such a high voltage on it, it doesn't give you any warning before it goes. So I've had a couple of amps where like one FET has gone boof, which sounds quite loud and scary because obviously it's a very high voltage FET. It goes bang like that, but it doesn't actually damage any of the rest of the amplifier. It just kills a single FET, and by the FET killing itself, it drains the caps of any power. So it's, yeah, it doesn't really do any other damage other than that FET going pop. Sissy Marlin says, so I'm kind of new. Do you have a contact info for amp repair? Or do you see this as a hobby? This is my full-time job, so yes, I can take on work, but only if you're based in the UK, because I'm based in the UK, and I've looked into having stuff shipped over here before, like people from the States wanting me to repair their stuff, and by the time it gets here and gets back, it's costs more than the amplifier's worth most of the time. So sadly, it's only really worth me taking on work if you're based in the UK. If you're based in the UK, then by all means, contact me on my Facebook page, which is NSV Audio. Just search for NSV Audio, and the picture looks like a oscilloscope with NSV written on it. And yeah, more than happy to take on any work you've got. Ah, Jesse's here. I must have missed your first message. How's it going? Jessie will be at work, I know, because at this time of day Jessie's at work. And then she always comes and joins me later. I put a cap in reverse polarity due to a hurry. Yeah, it went kaboom. We've all done things. I've done things like silly things like that as well. I've put ICs on the board backwards, upside down. I've done that before. Most of the time I notice it before I turn the thing on, but a couple of times I've turned it on and I've not noticed it's been backwards. Yeah, it happens all the time. We're only human. We make mistakes. It's part and parcel of amp repair. You're gonna make mistakes. It's just about minimizing the amount of mistakes you make. Yeah, I did something really stupid a couple of weeks ago. It was complete accident, complete fucking stupid thing. I fully repaired an amplifier, like beautifully, really complex repair, got it up and working. And the thing that killed it was after I put the MOSFET clips back on, you know, put the MOSFET clips all back on to the heatsink, and there was a thermistor which sat between two FETs, very close to them, and the thermistor has a metal back, and it sat between the low side FET and the high side FET, so there was a huge voltage difference between the backs of those two FETs. And when I clamped the thermistor in place, when I pushed it down, it obviously twisted a tiny bit, and it actually made a connection between the high side and low side FET, pin 2 of both those FETs. So then when I powered the board up, the high side and low side were connected to each other, and the thing blew up. Even on the low current supply, the thing blew up. But yeah, it's complete fluke. Like I never would have seen that coming. But it's now made me very conscious of the fact that when I'm putting those thermistors back on the board, that they don't touch any of the FETs. Will you show your signal generator setup sometime? Yeah, sure. My signal generator setup is really shite, actually. It's a really cheap piece of crap, and already some of the buttons have stopped working. I didn't buy it new, so I wouldn't recommend you get the one that I've got, but I can show it at some point, yeah. This clamp is so close to this transformer. I don't want to damage the transformer, so because these power supply FETs are toast anyway, I'm just going to shift the clamp over a little bit. You can see we've got a clamp here, which is far too close to this transformer. I can't get it out, so I'm just going to shift the clamp over a little bit so we've got some free space. There we go, that should be enough. How do you set your prices for repair? I generally go by the amount of time that I've taken on the repair and how expensive the parts are for it. Which is why, and someone, Tony on my live chat did not understand this when I explained it last time. So if someone brings in a £2,000 or $2,000 amplifier and it's got a small fault that takes me half an hour to fix, like RCAs or input circuit or something silly like that, then I will charge him the same amount of money for that half hour's worth of work as I would have charged someone if they brought in a $50 amplifier with the similar fault that took the same amount of time. I won't charge extra just because the amp's worth more. I'll charge it based on how long it takes me and how much the parts cost. Whereas Tony was completely confused and he was like, well, if it's a $2,000 amplifier, why aren't you charging more for that? I don't know, that's not how I do it. And that's why sometimes if someone brings in a really cheapo amplifier that's got a lot wrong with it and it's going to take me a little while to fix, even if the parts aren't that expensive, if it's going to take me a while to fix it, sometimes it's not worth the time. This has been worked on. This has definitely been worked on a few times before. We've got some strange screw in the case ground location. Okay. For signal generator, just use Audacity and your PC sound output. Buffer it through an external headphone amp so you don't risk damaging your PC soundboard. Yeah, that's a good plan. You can use Audacity. Yeah. Yeah, I just chose a signal generator because I didn't want to be having to use Audacity on the computer whilst I was live streaming and doing something like. Ideally, I just want to leave my computer to do the live streaming and not have to touch it. Because yeah, if I start trying to do Audacity on it at the same time and then navigating between screens and stuff, it just gets a bit complicated. So, and also another good thing about my signal generator is it can not only produce sine waves, it also produces square waves, triangle waves, and I can change the duty cycle of the square waves and the triangle waves. I can also do sweeps on it, and I can set a voltage offset, and it also goes up to 2 megahertz. So I can actually feed amplifiers with external drive clock signal to, you know, if I needed to do that to see if something was working or not. I've not had to do that yet, but I can if I need to. If I needed to bypass the drive circuit or part of the drive circuit and feed an external drive signal into the amplifier, I could do that. But if you just need a signal generator for bench testing amplifiers or like testing audio signal, yeah, you can download something onto your phone, something from the App Store or Audacity or whatever you need really. Afternoon, John Paul. How's it going, buddy? Any other case screws? Don't think so. I think that's all the case screws out. So I'm going to work on this one first. This is Ground Zero 4K. This appears to have a completely smoked power supply section, and I can't remember if the output section on this one's blown as well. But this one could be a little bit of a complicated and pricey repair. So
I seem to have lost all of my Allen keys. I'm not sure what I've done with all of those. Does a signal gen have an RCA output, or did you make some kind of splitter? No, the signal generator just has a standard. It has the same output as oscilloscopes have, the same output connection type that oscilloscopes have. So yeah, I just got like a bare wire adapter for that, and then I got some bare wire RCA connectors and then a splitter. You don't need both left and right RCA inputs when you're testing mono amplifiers. I've never understood why they have both left and right inputs, but you can only use one. But obviously, if you're repairing a 2-channel amplifier, then you do need both. Have you ever repaired a directed 1500D? No, but I think somebody's sending me one soon, so I might have a repair of one soon. I've got a feeling that I'm going to get one of those pretty soon. Check your floor, yeah. Yeah, I don't think I feel like I used them for something recently. I feel like I put them somewhere else in the workshop. But most of the time, yeah, things do end up on the floor. When I'm taking these amplifiers apart, I always like to leave the end plate for the power side attached to the board, so I then unscrew it from the heatsink, and the RCA side I unscrew the there should only be like 1 or 2 screws to do on this side, which makes it quicker to take apart, and also allows you to always check the correct polarity of the power inputs, because the board is the plate is still attached to the other end. So what I mean is, hopefully if I've done all the screws, they should slide out. Is there any left that I've missed? Yes, it's a BNC connector. Yeah, I actually spent the longest time trying to work out what the fuck that was called. I was typing into Google scope connection type, oscilloscope probe connector. I was like, I didn't know it was called a BNC connector, and it took me absolutely flipping ages to find that out. I had to ask some Facebook forum what it was called. Yeah, I've got BNC to bare wire, and then I've got on the frequency generator side, and then on the other side I've got bare wire to male RCA, and then female RCA splitter to twin male RCA. This is, oh yeah, I need to change my look. I need to change my text on the screen. So we just finished the Rockford, so I'm now going to put ground. I think this is nuclear 4K. So if I put ground 0, what the hell? I'll just put 4000 or 4K, 4K. Otherwise, it's not going to fit on my screen. Ground 0 4K. Okay, this should slide out now. I don't think there's any screws left in it. There must be something still stopping this from sliding out. Right, so the screws we've got there, that's taken out. One there, that's taken out. Not any over here. Those two are taken out. Ah, there's a case ground screw over here that's camouflaged.
now it should slide out. Nope, still not sliding out. What's it caught on? What's preventing that from sliding out? What the fuck? What the fuck? What the hell? There's no screws left in this thing and it's not coming out. The MOSFETs don't stick to the case on this one, so it's not that. This is actually using some really crappy thermal transfer pads. So I might want to change those when I come around to reassembling this. Nope, something's still caught and stopping this from coming out. It's almost like there's a screw still in the board, but I honestly can't see any screws left in the board anywhere. I wonder if these fan screws go all the way down into the board. I didn't think they did. Ah, it looks like they do. They're really quite long, actually. Usually these fan screws don't go all the way down into the heatsink, but perhaps in this one they do. There we go. That must have been what it was. Oh God, that was really stuck. Okay. Yeah, there's some really crappy thermal pads in this, so I might have to upgrade those. Okay, cool. Woo! There's been an explosion on something on the back of the board. So look, it's always good telltale signs. So if I can get the camera zoomed into here. So that has obviously had something go bang on the underside of the board. So if I flip the board over, we should see something very interesting on the bottom. What else has been going on? They've got some other marks as well on here. So this is all on the power supply section. Alright, so now let's put the heatsink down. Now let's turn the board over and see what caused that great big explosion mark. Holy oh my life. I'm not quite seeing what made that mark, but I'm seeing what caused the rest of the marks. So
Right, that great big discoloration. Was that there? Right, so that was, flip the board back, so that was literally just after these screws. So that looks like it was there. Okay, there is actually a small hole in the board there. It's not as big on the board as I thought, but something has gone bang big time on that section. Right, so I'm going to show you on the back of the board what this looks like. This is not going to be a cheap repair. Okay. So, first thing that we need to look at is this horrific mess of a drive transistor section. So all of this is all carbonized board, and all the traces are either burnt or missing. Oh my gosh. I don't know if this was like this before, or if like from a previous repair, or if it's done this in its most recent blowing. But the board here could possibly be conductive. Look, this driver's not even really soldered in properly. So this is a fucking mess. My phone's just ringing, so my stream will probably die, so apologies, because it always turns my 4G off. 1 second. Okay, I think we are back in business. Back on 4G as well. Alright, so yes, this section is obviously very, very nasty looking. Now the bit came from, it was just after the screw holes, so it's gonna, this is the bit that lines up with the mark. So on the other side of the board, if we flip her over, on the other side of the board, there is, oh fuck, there is a capacitor, a big capacitor. Okay, so I'm probably gonna go ahead and have to remove all these capacitors, because it seems that something underneath one of the capacitors sparked up big time on the board, and that's what could have took the power supply down. Very, very rarely, these big capacitors, underneath them, they can arc. If they, I mean, it looks like maybe this board has been subjected to pretty heavy vibration damage. This amplifier has been in for repair before, and you can see that it's been loaded up with loads of like silicone kind of sealant between all the caps and the driver board, etc. So I wonder if this amplifier was subjected to vibration damage quite badly at one point, and I think perhaps underneath one of these capacitors it is shorting on the board, which, I mean, that mark on the heatsink was absolutely huge. That was a big spark that caused that discoloration on the heatsink there. Yo, how's it going, guys? So if anyone's just tuned in and they don't know what mark I'm talking about, on the heatsink for this amplifier, if we look on the board, there is this beautiful, great big mark that's kind of rainbow affected, like that. A big fuck off spark has hit that. A really big spark has hit that, and the section of the board that lines up with this mark appears to be here, which is underneath one of the capacitors. So I wonder whether actually underneath that capacitor we have some shorting on the board going on. So I actually want to inspect that. This amp's an absolute mess. I wonder whether this is worth actually getting back up and running again, because the drive circuit area is so fucked. Like the board is carbonized to absolute hell. I really wonder about the reliability of this amp going forward.
Yeah, box mount will be fine. Oh man. Box mounting's good, it brings me business. This drink looks horrifically disgusting, but it tastes amazing. It's some kind of smoothie with kiwis and limes and other vitamins and shit. So, first thing that I'm going to do, before I start working on the power supply section, something caused the power supply to get fucked up big time. And there was a big spark in this area. So I'm going to remove this capacitor here that seems to have a spark underneath it. And if there is damage to the board under there, I can look about repairing that section of the board. Because if I repair the power supply section and there is still a bad area of board there, then the power supply will just kill itself again because there's still a short or something. So we need to sort that first before we start work on the power supply section. I'm going to boost my soldering iron temperature up to about 410 here, just to get this going a bit quicker. There's quite a high thermal mass on this area of board, and I haven't preheated this board. How is the stream audio today? I've turned my microphone up a little louder, but I'm wondering if it's clipping. If my voice clips at any point, let me know, because I'll turn my mic down a little bit. Seems all good. Okay, that's cool. As long as the mic doesn't clip. If my voice clips the mic, then just give me a shout and I'll turn it down a bit, because I hate this listening to someone speaking and their microphone is clipping. It drives me nuts. Sounds horrible. We had the first bit of nice weather over here in the UK last week. Thursday was, well, I say nice weather compared to how it's been recently. So I think the weather got up to like 12 degrees Celsius, and it felt really hot. The sun was out. I was chilling outside with my friend in his backyard, and I had a t-shirt on, and the sun was out, and I actually felt really hot. Like, not really hot, but I felt warm and comfortable. And apparently it was only 12 degrees. So spring cometh, I think. Which is about damn time. Not clipping, but these low frequency notes from the buses are noticeable. Yeah, I'm aware that they're noticeable. If it's a problem, if a few people have an issue with the low frequencies from the buses, let me know. I'll try and put a filter on it. What are you doing to the amplifier? I'm inspecting underneath this capacitor. I think I have my YouTube live stream set so that you can scroll back through the video. So you can like scroll back a little bit. So if you scroll back about 10 minutes, you'll see exactly what's wrong with this amp and what I'm doing to see whether this is even worth repairing. This thing is an absolute mess. If you're watching on mobile, I don't think you can scroll back. I need to cut the silicon off so I can actually remove this cap. I don't know why. I love this silicon stuff. It's really cool. It's a really cool, very cool, unnatural material. You never get to feel something like that in the natural world, really. Oh my goodness. Okay. Right. So I've desoldered the cap. So let's see what we got hiding under here. Okay, come on, off you come. Okay. Ha! Okay, interesting. I was not expecting to see that. It's actually whoa! Hang on a minute. Wait a sec. Wait a minute. Let me just inspect this for a second. I was going to say, so there's no marks underneath the cap. It looks beautiful. It looks fantastic underneath the cap. So it wasn't shorting under the cap, but the mark on the board has obviously happened for some reason. Now this cap does seem to have a massive gash in the side of it, or some kind of perhaps a vent in the side. So I'm wondering whether I'm going to check the continuity of these caps. You can sometimes shake a cap, and if it wobbles inside, it's fucked. But I wonder whether some of these caps have shorted, and then it caused a huge current spike, which blew one of the traces on the board. That might have happened and caused the spark. So I'm actually just going to inspect this little. There's a mark on this capacitor that I'm just going to inspect for a sec. I'm going to take some of this casing off. I'm just going to see whether this cap has been damaged. Okay, now this looks okay. So what I was looking at is on this cap, there was actually focus. There was actually a hole in the casing here, in the protective casing, that was like here. But the actual cap itself seems okay. I think it was just hit by, because this MOSFET on the board here exploded in a horrific manner. You can see this exploded in a horrific manner. So I think some shrapnel from this actually just hit the cap and punctured the casing a little bit. Didn't actually puncture the cap, but it punctured the protective stuff around the outside. So that's maybe going to be okay. We do need to see what went on with that big sparking area on the board. Very interesting. Okay, next I'm going to take my multimeter, and I want to see whether there's any short circuits on the rails here. So these capacitors, these are the rail caps, so these will smooth out the power supply switching and provide some kind of dampening for the output section to draw from. So yeah, we shouldn't have any short circuits on here. Yeah, Nicholas has got a point actually. That mark could have been there from factory. So I could just be searching for something that's non-existent right now. Alright. Well, I wanted to check that anyway. That's fine. I'm going to leave the cap out for a bit. Because there's no need to put that back in just now. I can put that back in a little bit later. So first thing then is we're going to start with the power supply on this amplifier, which, as you have, if you haven't already seen, the power supply is completely mutilated. Yeah, it's every single power supply FET has exploded in a very dramatic manner. So yeah, first things first, we're going to remove all of these. Just to remove them, I'm going to actually just snap the legs off first, because the drive circuit, the driver area circuit on this amplifier is also very badly burned. So if I can't have the drive circuit working properly, then there's no point going through and doing all this to the FETs, like desoldering them properly. If the stream keeps buffering, I apologise. My OBS keeps knocking down a little bit. I think I had Chrome open and it was eating up my CPU, so I just closed Chrome. It should work fine now. Shouldn't get any more buffering from now on. Wiggle, wiggle, wiggle. Yeah, buffering. Yeah, I should have fixed the buffering. It shouldn't be buffering anymore. Okay. Now, this amplifier has obviously been repaired a few times. So, the power supply obviously died on this occasion. Let's push this to one side. But when the power supply dies, it doesn't always kill the drive circuit. And this is just raining bits of carbonized FET. And now, obviously, this power supply drive circuit is in very bad condition. You can see here on the back of the board, there's not really any of the board protective coating left itself. We're right back down to the actual PCB filler material there. The traces do seem to be mostly there. So yeah, I'm curious to see whether the drive circuit got killed this time, because it doesn't always get killed. Depends how the FETs blow. Now, I'm just going to check for obvious shorts on these driver transistors. Yeah, I think these are fucked. We've got 76 ohms between 1 and 3. That's not right. Okay. Yeah, no, these need replacing. Okay. $150. No. But kind of be careful with this, because this area of the board is obviously quite badly damaged anyway. So I need to be careful, because any heat that I add with my soldering iron won't help with this going forward. What's the best 12-inch sub? My budget is $250. That's a really difficult question, because I don't live in the same country as you. So you will have lots of different brands available to you that I don't have, and also all of the brands that we do share will be different prices. So unfortunately, I'm unable to advise you on that. Because the markets in our countries are too different. Prices and what kits on offer is too different. I'm going to turn my soldering iron temperature down to around about 330. So 330 degrees Celsius. I don't know how accurate this AOE soldering station is with its temperature readout, but 330 on my meter is generally about the right sort of temperature for this delicate stuff. Sometimes when removing this old solder, it actually works better to apply some fresh solder first. Makes it easier to come out. Yeah, this is working quite nicely. We're not doing too much. Belgium Online, missed your live streams. Yeah. I haven't been doing any for the last week. I've been pretty busy with some other stuff. So, but yeah, back in business now. Got a very busy week of amplifier repair ahead of me. So, I'll try and live stream as much of that as I can. I'm not sure if you saw then, but I actually just touched my pinky finger on the soldering iron. It was quite hot. Don't recommend doing that. So I'm just removing most of the solder from these holes first, and then I'm going to go ahead and see how wiggly they are in the holes. Hope you live stream more tonight. Yeah, I'll be live streaming till pretty late this evening. This is why the video is titled like a long day of repairs, because I'm going to be live streaming for the majority of today and well into this evening. So, oh wow, yeah, this transistor is definitely fucked. Okay, next one in here. These traces are very, very delicate. I think I'm going to lose some of these pads actually on the back here. Yeah, these traces are incredibly delicate and mostly fucked. Yeah, so you can see here on this one, got a nice big bulge in it on the front. So that's very fucked. With your distortion detector speaker setup, how high of a frequency can the capacitor still filter out? As in, what point will it start working as a crossover? It depends. You need to look up the ratings of capacitors used as high-pass filters, because it depends what ohm speaker you're using with that circuit. So, you know, the very small speaker that I used, I think that was like an 8 ohm speaker. The higher ohm your speaker, I think the higher ohm your speaker, the higher the frequency that it filters. So, like a 2.2 microfarad capacitor, if you use that with a 8 ohm speaker, let's say, I can't remember the exact figures, but like, for example, it might be 18 kilohertz. But if you use the same 2.2 microfarad capacitor with a 4 ohm speaker, it's now like 14 kilohertz. So it depends what value, what impedance speaker you use alongside the capacitor as to the frequency that it filters. You can go to Google and you can find a comparison chart of farad versus frequency for high-pass crossover capacitors. Buff them with solder and melt and pull them clean from the vias. I can't do that in this case because the pads all look like this. Like, it's completely fucked. So if I load this whole area up with solder, I'm going to just pull all the traces and all the pads off the board. So I've got to be really, really careful with this one. Which is why I'm taking so much time with it and being very careful not to further damage any of these traces. Because yeah, usually I just load up a great big blob of solder on top and pull it all out. But if I do that here, it's just going to pull all the traces off the board. So I'm just trying my very, very best to save as many of these pads and traces as I can. We're doing well so far. We haven't further damaged anything that I can see. You're a 139. Okay. Euro 139. So the 140s are in the middle. Okay. Do they need to be bipolar for the high pass? Yes, there needs to be non-polarized caps. If you use a polarized cap that has a positive and a negative, things are going to go exploding. You need a cap that is rated for AC voltage. DJ H. Afternoon, how's it going? Alright. Oh man, this is a mess. Okay. Right, so drivers are removed, and you can see that it's still a mess on the top. I'm gonna check whether these resistors and stuff survived. I think they did. I think they look like bad condition, but I think it's just where they were covered in soot and stuff from the actual transistors themselves going down. So these resistors from memory should be like a low value, like oh, these are pull downs. If they're pull downs, they'll be high value. I think these are the pull downs. So, so we should have, yeah, they're purple and yellow, so we should have 470 ohms. Yeah, so that's a lowish value resistance. So I'm just making sure these are all around about the 470 mark. This one reads 300 and something. This one's reading 322, which is a little off. And this one's reading 466. So I wonder whether that's due to the resistor being bad, or whether there's something else in the circuit, because there's probably some solder bridges on the other side. This diode is reading 10 ohms by the looks of it. This diode is reading 9 ohms. Whether it's the diode or whether it's something on the board, though, that's yet to be known. Yeah, this looks like fun, Nat. Yeah, I'm just going to make sure that there's no solder bridges or small bits of solder that are left over that were making a connection between any of these pads. So that needs to move over there. This is an absolute mess. I'm curious actually as to whether the board itself is now conducting, carbonized. So what we can do is to check whether the board is carbonized and conductive, we can set our multimeter to the highest ohm setting, 2 mega ohms, and push our probe into one section of the board and then the other probe into the other section of the board. So not touching any of the contacts, or like with one of the things in the board and the other one on a contact, we should have absolutely nothing on the multimeter screen. If we have any readings whatsoever between the board and any of these pads, or the board and the board, then the board is conducting, and that's not a good sign. So let's see. So I was touching on this trace over here, so it wasn't the board itself. No, I think we might be okay. I don't think this board is conductive, so that's a good sign. Alright. Now let's just check that diode again, because on that diode we had 10 ohms a minute ago, and that wasn't, I don't think we should have had 10 ohms there. So we're still showing 10 ohms on this diode. So I'm just going to lift one of the legs of that diode and see whether the diode reads 10 ohms, because if it does, it's fucked. My total is up to 3 amps repaired now, thanks, says Dan. Fantastic, man, that's wicked work, nice one. It's a really good feeling when you get something working. What PWM chip? What PWM chip does the Ground Zero use? It's a 494. Yeah, 49. Or KA7500, same thing. So let's lift this leg of this diode and see whether our 10 ohm resistance goes away or not. Okay, that's the diode lifted. Now let's see, is the 10 ohm resistance on the diode or is it on the board? It's on the diode. So this diode is toast, so that needs to go. I need to check if I have some of these spare diodes. I can't remember what the diodes it uses in this section of the board are. I've got a feeling that it might not actually need these diodes. There are some diodes and components that are put into these boards that are no longer needed because they were implemented back when board design was much less advanced, and that nowadays they're not required. This is some stuff that Gordon, the amp doctor, has told me about, because obviously he's been doing it for many years, so he has more knowledge about the stuff that really should or shouldn't be in the amplifier design. And I've got a feeling that these diodes aren't actually required. Okay. Could you clarify something on a previous video relating to the clipping video? I tried determining the clipping on my mids amp. Yeah, I've said this before, you can't do it with mids because on mid-range you can hear the clipping through the mid speaker, so there's no point doing that. This clipping detector is only really useful for setting up subwoofer amplifiers. To detect clipping on your mid speakers and mid amplifiers, you just turn it up until it sounds like shit, because you can hear the clipping through the mids. You can't. The reason that you need some detector for the subs is because subwoofer drivers are they don't play that, you don't get high frequencies through a sub driver. Even if you try and get a sub to play high frequencies, you won't hear the clipping unless you're maybe standing right next to it and you know what it should sound like. And especially with all the bass going on in the car, it's very hard to hear whether the sub is making a clipping sound or not. So, but with the mids, it sounds nasty. It sounds horrific the second it clips. So you can, you don't need a clipping detector for mids. Just use your ears. Okay, I've just realised I've removed that that diode without checking the polarity, so I'll have to scroll back through my live stream to remember what way round that went. But because obviously it's burnt off the board, so usually it would show you the polarity on the board, but this is so burnt that it's not going to show. It's not going to show anything. You should unsolder the FETs or break them. They are. The FETs are off. Look. So this is the output section FETs. These are fine. We don't need to take those off the board yet. We are just working on the power supply drive circuit. So when it comes to fitting FETs in the power supply section, then yes, if there's a problem in the output section, we'll remove them. But at the moment, we don't need to touch this section. We're literally just working on this tiny, teeny circuit here and getting the drive circuit working. I don't need to touch the output FETs for now. Yeah. So alright, so what is this diode anyway? Let's have a look. See if we can read what it says. It says O0 sorry. Get the light on a little bit. C10 perhaps. 5. It looks like it says C10, and that possibly is it. And then just underneath it, there's a 5 and then a T. So C10 5T. Let me try Google that, because I might have some spare parts for this. Diode C10 5T. Let's see what comes up. So it's potentially a 10 volt. Ah, jeez. Potentially a 10 volt Zener diode. The 5T could be the batch number or something. Let's see. Do we have a data sheet for this? Yes, we do. 5T could be 5 tolerance. 5% tolerance is the 5T. That could be what that means. So this is going to be the C10. So yeah, this is a 10 volt Zener diode. And very annoyingly, I don't think I have any 10 volt Zener diodes. I've got some 12 volts, and I've got some 5 volts, and I've got some 36 volts, but I don't think I've got any 10 volt Zeners. I guess we'll have to have a quick look in my drawers. See what I've got. So this is a 36 volt Zener, so it's not that one. One N47, that's going to be a 47 or 44 volt. Not that. What else do we have? Any old Zeners in here? I might be able to nick one from a donor board. There might be a 10 volt Zener sitting around on a donor board. Nada más diodes aquí. Uh, 39 volt Zeners, not those. use a lower frequency on the mid or the tweeter amp for clip, and then adjust your frequency crossover. That would work for signal clipping, but that won't work because the amps will clip at different points for different frequencies. So you want to play the frequencies that you're going to be actually listening to. This is a C12, so this is a 12 volt Zener, so that's not good either. I wonder if how much of a difference that will make. Can I get away with using 12? I'm not gonna lie, I'm not completely fully clued up on the Zeners and their exact like purpose and like using different values. Like if we use the higher voltage Zener, what exact difference that would make. What about this one here? We've got a couple of small diodes in here that are just loose. Let's read those. C12, okay. 12 volt. This is one of those ones with a crazy horrific. Yeah, that's I know that's not a 10 volt. So I don't think I've got any 10 volt Zeners. So I might have to order some of those. But I think I should be able to check the rest of the circuit and get the rest of the stuff up and running without fitting that diode. So let's do that. So we've removed all of our drivers. So what I can do now is I'm going to check to see whether the TL494 was damaged, because this area is fucked. So I'm going to put some power to the board, and I'm just going to probe the areas on the drive circuit that the 494 should be sending the PWM signal to. See whether it's present and see whether it looks good or not. Yeah, you can tune full range amps by ear, no problem. It's better than trying to do it some other weird way. Okay. So let's see. Did the 494 survive? Turn my scope down a bit and go to that setting, reject low frequency. Yep. Right, so I'm just going to turn the amp on and make sure it doesn't draw any excessive current. Doesn't seem to draw any current whatsoever, which is good. Means that there's not anything that's mad shorted out. So let's see about these drive waves. Okay, so that's one. It's drawing 0.2 amps when the relay clicks in, which makes sense. So which means that the relay coil will be drawing 0.2 amps, which is fine. It looks a little bit noisy. Looks a little bit. This is 26 kilohertz, which is about the right sort of frequency. Jumping around a little bit, but it generally looks okay. That's a 5.5 volt RMS signal, which is about right. .5 volt RMS, yep, okay. Yeesh, that doesn't look good. Okay, so there's something that's not good here. Yeah, there's... oh no. Right, okay, let me try and see whether I can show you what's going on here. This is very important. This is going to make all the difference as to whether this thing is going to explode again. Right. So we have spaces here for 8 driver transistors. Okay, we're going to have 4 PNPs and 4 NPNs. The NPNs should have positive 12 volts on the middle pin here. We can see here that we have our, well, we've got 9 volts because that's what we've got going on the amp at the moment, but we should have our B plus battery positive on the middle pin of the NPNs. Okay, and you can see it here. Because the traces are so badly fucked, they don't all have it on the top of the board. Some of it want to be on the bottom of the board, so I have to go upside down to check it. But yeah, on the PNPs, we should have 0 volts, completely nothing, on pin 2, being the middle pin. So this one, we have completely nothing. Give it a wiggle, there's still nothing on the screen. This one over here, we have completely nothing still on the screen, which is good. And this is the PNP. This one over here, however, you can see that there's about 0.8 volts leaking. Let me zoom in a bit. So we've got 0.8 volts leaking and some leaking square waves going to this pin. So I think the board is actually conductive here because there should be 0 volts on this pad. And the same goes for pin number 3 over here. We've got almost the drive wave, which shouldn't be there. The drive wave should only be on pin 1 over here. See, this is pin 1. This is the drive wave. It should only be there. On this pin, we should have nothing, but we have some kind of noise there. Now, it's possible. No, because hang on a minute. No, the diode is on the other batch that I took off. So that, oh yeah. I'm just going to check either side of these diodes, because the diodes have the drive wave on them and then it pulls it to ground. Yeah, so the diodes are fine. They're not causing the issue. I think the board is conducting between these pads, because on the NPN we should have drive 0 volts. Oh, that one's got a little bit of something. Oh, sorry, on the NPN we should have drive 9 volts. Yeah, drive 9 volts and then 0. So NPN should be drive 9 volts 0. Yeah. On the NPN of the other side we have drive 9 volts and then 3 volts worth of noise. So that is conducting through the board. And on this one we have drive 9 volts 0. Good. Drive. And this is the PNP, so we should have drive and then 0 volts, which we do. And then again 0 volts. I think this we should have 0 volts again. Yeah. So this one here, this area here is problematic. We have something going on, probably where power is being conducted through the board itself. Through the burnt PCB is conducting electricity. Yeah, we can see that there. We've still got 9 volts on here, which is correct. We should have 9 volts on the NPN. And there's like 0.6 volts there. And on here, there's like some small voltage as well. But it's the voltage leaking is mostly there when the drive wave starts. So yeah, it's leaking from somewhere where the drive is. Yeah, this is what shouldn't be there. Okay. So yeah, I need to inspect further with this and find out what the flipping hell is causing that. And it's probably going to be the board is actually conducting, which is the worst. This is the worst possible scenario. If the board is conducting, that is the worst scenario. Okay, so power supply off. And what I'm going to do is I'm going to actually dig out some of this carbonized burnt section of the board here. Then I'm going to spray her with 99% isopropyl alcohol and see whether the carbonized conductive sections of the board were just on the top layer, and by scratching the carbonized areas away might resolve that. So yeah, I'm just starting to scratch away a lot of this carbonized crap on the board, and it goes all really fluffy, as you can see. Very, very badly damaged board. If this is if I can't get this to go away, then we may have to mount the drivers externally outside of the board. So I'll have to cut all the original traces and I'll have to mount the drivers externally. You can see how badly this has been burnt just by how much of this stuff I'm digging away and how much is coming off. A good section of the board should be completely solid. Like, you shouldn't be able to do any of this with, but this is soft and fluffy because it's been really badly damaged by the heat. Hey Bevis, I have a question. Go for it. What's your question? I feel like using a Dremel would be far too violent on this. Fuck's sakes. This is fucking, this is ruined. Yeah, so we're actually getting a nice hole here now in the board. I don't think I'm too happy mounting these back in the original locations. I'm really wondering whether I should just do an external circuit on this. Or at least a couple of the legs not mounted. Yeah, so now I've got a nice big hole in the board here, so this section was completely fucked. The fact that it's turned into a hole. It's not so bad over this side. I mean, it's bad, but we're not going to get a hole. Right. Okay. Let's power this up again, and I'm actually gonna stick my oscilloscope probe into the PCB, into the actual board itself, and see whether we get any voltage spikes or anything on the actual PCB. Because that will show whether there's anything leaking into the PCB. Alright, so I've turned the power supply on, so we've got 10.2 volts going in. I'm actually going to increase the input voltage up to 14 volts, and that will help me see any leaks, because the higher voltage will pass gaps a lot easier than the lower voltage will. So I'm just going to give it 14.4 volts. Okay, cool. Let's start probing stuff. So I'm going to probe just the board, not the pads. Wow! Holy shit! Look at that! I'm touching the board, and look, we've got 4 volts on the PCB. So we've got. So see, we should have 14 volts. We should have like 12 or 14 volts here, which we do. We've got 14 volts on this pad here, which is this is the pin number 2 of the NPNs, but it's leaking into the board, into the PCB so badly that over here it's giving us 5 volts. Yeah, this is majorly fucked. So I'm gonna have to cut all of this away anyway. The other areas seem okay. I'm not seeing any voltage leakage in the other areas. Right, well, let's cut that bit away then. Let's cut that right back. Oh my life. This is absolutely...
So yeah, they see this amplifier either went down again because the previous repair tech didn't sort out this this burnt trace area, or this happened in its most recent failing. Not too sure which way around it happened, but okay, now we're finally starting to get to some solid board. So I'm scratching away all this bad crap, and I think I'm finally getting to some solid board. Ah, that's a nice big hole, isn't it? I'm trying to remember where this trace went. So I've got a trace here. I think that, yeah, that trace just goes to this resistor. That's fine. Didn't go anywhere over here. So the trace that provides the B plus was here. You see, it went here into there and also into there, which is for the NPNs. We lost all of the trace for the pins 3. Pins 2 and 3 we lost all the trace for. So I'm going to have to work out where they went. And we can do that because we've got some 3 left that are intact. So yeah, this is a fucking mess. So let's turn the board back on, and let's see whether that leaking voltage on the board has gone away. We're still going to get the 14 volts here because the trace is right here. But what we shouldn't have is we shouldn't have it underneath the board. Oh, we still do. We've still got like 3 volts worth of it under the board. But as long as it doesn't, as long as it's not showing up on any of these other pads, then this is salvageable. So it's obviously there, which is fine. As long as that 14 volts isn't showing up anywhere. Now I'm going to turn the amp on and see whether the drive waves are surviving. Okay, so the drive wave is present there. That's good. That's still our positive 14. So we should have drive, B plus, nothing, drive, nothing, nothing, good, drive, B plus. Why do we not have B plus on this pad? I think that's because underneath we don't. That's right. I need to probe it from underneath. The B plus is on this trace, which is fucked on the underside. Right, okay. So we're missing B plus on this pad here. And that's because it comes from this trace. Okay, cool. Now, interestingly, we're still getting some small voltage leaking from that, and that's leaking from there.
I think that might be okay once this pad is connected. That might be okay. Yeah, okay, I think we're actually ready now to make a bodge attempt. Oh wow, this look, if I stick my probe into the board still, it's still conducting. This area of the board is still conducting this. Alright, let's cut some more of that away. So just to see whether this is going to be worth repairing going forward, I'm just going to very temporarily mount some new driver transistors into this location, and just like connect the pins up with some jumper wire, some temporary jumper wire, because if there's no point me going and doing some extensive like rebuild of this area if it's not even worth repairing anyway. Because at this point, there's, you know, I could actually use, I do have access to some driver boards which are universal. You can get them from the Amp Doctor in the UK. He made his own and had his own boards printed, which are basically power supply drive circuit boards. So if this is unsalvageable, I could just hit him up. Like call him up and just get one of those universal driver boards, and what I would do is I would disconnect, like cut the traces on this original circuit, and his driver board just runs off of the original TL494. So you take a jumper from pins 9 and 10 of the original TL494, and then you just run it to his piggyback board, and you just mount it somewhere on the board. And then you can run the power supply FETs off that if you've got an issue on the main board like this. Is this the HCX version? I can't remember, I'm not too sure. Yeah, I think the sticker's on the back of the case. I'll have a look in a little bit. I can't exactly remember. Right. Okay. So we are missing a Zener diode. So we might see bad drive on, or like less than ideal drive on the area that's missing the Zener diode, because I need to order one. But just out of pure curiosity, let's load up some replacement drive transistors. Ah, shite. Now. I can't remember, because the board is so badly damaged. It's obviously not, the markings are no longer present, so I can't remember which way around these drivers go. No, actually no. What am I talking about? Of course I know. The drive will be on pins 1, so that's obvious. So yeah, this is pin 1, so it goes that way around. Okay. So yeah, I'm gonna have to do some soldering to the top and the bottom of the board. I'm actually gonna have these extended pretty high with the legs sitting really quite high up. We're just gonna have to resolder the traces on. I'm gonna do one at a time so that I've got more room to work in here.
I'm going to take my very small soldering iron tip for this. Why not just use an inch of breadboard? I don't have any breadboard. I never bothered using it. I never needed to. I've never done any circuit board prototyping, so I've never needed to have breadboard. I'm doing the top board first because these vias will all be fucked, so we have to manually solder it from the top and the bottom of the board to ensure a good connection. This is the fun one. This is the one where we go through the hole. So I'm going to put this one down a bit lower so I can then bend the legs out at the bottom and fit them where they need to go. Okay. So that's the PNPs. Now let's take some NPNs and do the same from the top of the board. NPNs are all in here. 139s.
Almost there with the top of the board. Almost there. I'm scratching off some of the insulation on this trace because this trace is actually the B+ that provides the NPNs with the power. So I may want to solder a small jumper wire to this trace, or I may do it from the bottom of the board, but I'm just scratching that away in case I decide to do it from the top of the board. Actually, I might not even need a jumper. I can probably just do it like this, where I do that, and then that leg, actually, I don't need that much. No, I've bent too much. I just need a tiny little bend on here, and I can solder that to the trace. This is all just very temporary, just to see whether this thing's actually even going to be possibly working or even worth a repair attempt. Okay, there we go. I think that might have actually been some bass, some subwoofer setup. That was quite a big bit of bass. That was. Did you hear that? I don't think that was a bus. I think that was actually a subwoofer system outside. Someone playing some bass. Yep, that's pretty solid. So yeah, we just bent one of the legs, and then I've just attached it to the trace on the top. Okay. So now we flip her over and we sort out all the stuff on the bottom, get all that hooked up. So we have a couple of traces here. We have this one here that goes to both this leg and this leg. So if I trim this leg down, it's a great amp and a simple fault. I wouldn't say it's a great amp, it's like an average amp. And it all depends whether the customer's willing to pay what this is going to cost. Yeah, obviously, you know, I like a challenge. I would like to get this up and running, but that looks oh my gosh. If this actually works, I'll probably just douse the whole lot in CA glue, which will make it impossible for the next repair, but oh well. Right, so the trace that went to that leg was here. See this trace here? That went to that leg. So if I scratch off, actually, yeah, if I scratch off some of that, let's get my scrape off the insulation on this trace here, and now I can just bend the leg over on top of the trace and apply some solder. This stuff is literally just floating in the air. Yeah, I'm actually going to trim that. I'm going to trim that trace off a bit because I can't get my cutters in there. Yeah, just trim a little bit the trace off, makes it a bit easier to bend this down. So I'm just going to bend the leg of this down on top of the trace. Use my tweezers as a lever. Push that down onto there like so. And then apply some solder and push it down, and that should stay nicely. Apply some solder to the trace as well. Cool, that's pretty good. Right, so that's that one. So we've got that connected, that connected, that connected, that one's connected. So then we've got these two over here to do. That's going to be pretty simple. Just need to pop that back through the holes. That one through there. And this one through here. Why does this trace look like it looks like it's too long now? Do you know what I mean? It's kind of not. Yeah, this trace almost looks too long. Weird. This looks like it should go around and marry up with this one as well, I think. I think these two should be connected, yeah, by the looks of it. If we go by the multimeter as well. So I might just use a solder blob for those. Yeah, these two should be connected. But the trace here, I've already soldered that down, so. Okay, so I'm just going to use a solder blob on this one to connect those two together. I'm just going to put that through the hole there. Like so. Yeah, this is just a really temporary little workaround to see if this is actually going to work or not. If it works, I might decide to neaten this up a bit. There we go. Okay, now let's do the middle leg. I think that's most of the really bad traces out the way. The rest of it should be relatively straightforward now. Ah, I've just realised why that trace was too long. I've made a mistake there. Look, you see this? You see this one? That's meant to be on pin 2, not pin 1. Stupid ass. That's why that seemed like it was too long. It's meant to go on pin 2. Just shift that over to pin 2 where it should be. There we go. Back where you should belong on pin number 2. Very nice. And the last ones to go on, all these around this area here. Right, I think that should do it. Should just about do it. Alright, okay. Let's check continuity. So we should have continuity between these two. Yep. Obviously these two have continuity, and then these two obviously do, and these two. Okay, so we should also have continuity between the drives of these two. Yep, yep, and yep. We should have continuity between all of these ones. So here and here, here and here, and here and here. Okay, that's good. So yeah, it looks like that we've done an okay-ish job on that. Let's bring that back around. We are still missing that Zener diode, but I wonder what difference that will make. I'm just going to trim a couple of the legs here so they don't get pushed down when I put the amp back. Just trim that one. Trim a couple of these off so they don't... Because yeah, when you put the amp back down, it can push the legs and short out against its neighbour. So let's just trim those short if they're too long.
Yep. Okay, cool. No. Okay. Oh, goodness me. Now, obviously, all these gate resistors are completely fucked. Well, they look fucked, and most of them probably are fucked because they have all either got covered in soot from the FETs blowing, or they have blown themselves. So some of these look very bad, actually. So yeah. But also the pull-down resistors can also be damaged quite badly. So to check the pull-down resistance, I'm going to turn my multimeter to like 20k, 20 kilo ohms or something, and we're going to put the black probe on the ground, and we're going to put our red probe on the before the gate resistors, and I'm going to compare the resistance between all of these batches. So we've got 400 and this was a bit what I did before, 460. So we've got a 460 pull down there on this batch, this bank, sorry. You've got a 472 there, a 469 there, and this one we have a 406. So okay, wicked, cool. So the pull down resistors are all fine. So I'm safe now to turn the drive. So oh my god, look at my hands. Ugh. I'm safe now to turn the drive circuit on and see whether our repair that we've attempted to this area is actually going to work. And we are still missing one Zener diode, so the drive wave might look funny on one of these banks. Let's find out. I'm going to turn my power supply back down from 14 volts to like 11 or 10 volts. Make things a little safer if anything goes wrong. There we go, 10.7, that's fine. Right, let's see. So we're going to probe the start of one of these gate resistors before the gate resistor. Okay. So we're not getting anything there, we're just getting tiny pulses. So that one is not working properly. Okay. None of these are doing anything. Did I put these back in the right way around? The drive wave should be on leg 1, shouldn't it? Not leg 3. I may have put these in backwards. That's going to be fucking annoying if I put these in backwards. Because there's no markings on the board, I can't really see which way it should be. Yeah, something's the TL494 is under too much load. It's not actually the drive waves aren't actually they're being pulled down straight away. So I wonder whether these are in backwards. Because we can't see the orientation anymore, and I was stupid enough to not check the orientation before I... Yeah, it's saying that my stream health is low. Oh wait, stream is healthy. Okay. Okay, I think I sorted it. Not sure what was going on there. Apologies, guys. Yeah. Anyway, so for some reason the drive isn't good. It's not present. So I wonder why that is. I'm gonna have to remove all these again now. I'm gonna try flipping the drivers around. I'm almost certain that it should be pin 1 with the drive on it, and then the output is pin 3. But I could be wrong, because we haven't got any markings to go with, so I'm gonna try and flip some of these around, see if that makes a difference. I'm gonna flip 2 of these round that aren't badly damaged. Nidfrost, how's it going? So just to make my life easier, I'm just going to flip these 2 round, which are ones that didn't have really bad traces on them. Just tuned in. How's it going, buddy? This is an absolutely flipping annihilated board that we're working on at the moment. Absolutely annihilated board. It's got a hole in the drive circuit area. Lifted traces, all sorts. For future reference, I should have just tested 1 bank of these drivers before I soldered them all in to ensure the orientation was correct, because we haven't got any markings on the board to go with. Before I soldered them all in, so I wouldn't have to desolder them all again if I got it wrong. So I'm just going to flip 2 of these around and see if it starts working. I don't have another amp that's like this to compare, no. Alright, so let's put these in the other way around and see if that changes anything. I usually have similar amps in the workshop to compare, but at the moment I've done quite a good steam of repairs, and I've got most of these big amps out of the workshop. Can't quite remember. Alright, let's try that then. Just make sure that it's soldered to the top board as well. Yep. Alright, so 2 of them are flipped around the other way around. Let's see if that has made any difference whatsoever to the drive on those ones. So that bank will be over here. The remote was removed from the amp. Oh no! They were backwards. Oh no! That means we've got to go and flip them all around. I had a 50% chance of getting it right and ended up getting it wrong. So for reference then for you guys, the drive wave from the TL494 should be on pin 3, not on pin 1. In this design of circuit anyway. Okay, right. Let's flip them all around then. Gordon had gate driver boards. Yes, I've used Gordon's gate driver boards before, and I actually mentioned them earlier on this stream. I was saying that we could use one of Gordon's boards, but I don't have any in stock at the moment. But yeah, Gordon's boards would probably be a much quicker way of fixing this, but I don't have any of those with me just now. Okay, well at least we know that there's not another issue somewhere else, so we can just flip these around and these will all work. Alright. Even though it's a little bit more work. So I should, in hindsight, I should have only fitted one of these sets first and checked the orientation was correct before fitting all the rest of them. Especially these ones that are really fucked. Beverage, you can save a whole lot of time by using an FAN3122C IC to replace all those transistors. 9 amp sink, 7.1 amp source, low delay, efficient. Oh wow, that's pretty cool. That's a cool bit of advice. Thank you, Nicholas. I can't use it now because I don't have one of those, but I'll look into that for future. Okay, now that's all of them out, let's flip them round and refit these. So yeah, future reference for anyone doing any repairs on this where you can't see the markings for these transistors anymore. What I've learned today is that the drive from the TL494 needs to be on pin 3 and the output from these is pin number 1. I assumed it was the other way around, because I don't think I've ever had to do quite an as extensive of repair on the drive circuit like this, where the markings are actually all burnt off the board like that. So yeah, really interesting. 4 hours already. Yeah, we're not 4 hours into this amplifier. We already fixed some Rockford Fosgate. Yeah. What did everybody get up to at the weekend? Because what is it? It's Monday, isn't it, today? Yeah. Anything audio related? Anything bass related? Did anybody build anything? Did anybody go to any shows?
Rebuilding my car, I just ordered PCB for my own amplifier. Oh wow, maybe start producing engineering's next sample. That's fucking cool, man. Good job. Nice one. That's something I want to do at some point in my future, is design my own amplifier and have it produced. That'd be very, very cool. Upgraded my amp a little more wattage. Surprisingly, it sounds cleaner than it already was. Ah, cool. What upgrades did you make? What changes did you make? Did you thicken up the traces, replace the capacitors, fit higher current MOSFETs? Did you rewind the transformer for higher voltage? Did you increase the power supply switching frequency? Planning the layout for the enclosure in my Toyota IQ. That's a really, that's a really small car, isn't it? I think. Is a Toyota IQ a really tiny little car? What are you going to try and fit into there? Connect it again. So now let's do the bottom of the. Now let's do these bottom traces once more. Really tiny, 2x DD506. Ah, they're really cool little woofers though. I've actually heard them get pretty loud actually. Yeah, they're really cool. I like those woofers. Yeah, for 6.5s they definitely get loud. A friend of mine had 4 of the 6.5s and he was doing 145 dBs. He then got 8 of the 6.5s and he was then doing, wait for it, he was then doing 150 dBs from 8 6.5s. Really, really cool little build.
Okay. Hi, I sent you a message after watching last Tuesday's punch amplifier repair. Started to check is out by my own with some very small amount of knowledge. So far there is found one broken rectifier. Do you mean the rectifier has snapped legs? The rectifiers very rarely blow, like they very rarely go short or actually get electrically damaged. The rectifiers for some reason often seem to have very brittle legs compared to other components on the board. So usually when a rectifier is damaged, it's snapped legs. All right. Let's see if that's enough. Let's see if that's enough to see if this is going to work. So, power, supply on, 0 amps being drawn. Let's see. Drive wave on that bank. How about over here? Yep, drive wave over there as well. And over here. Yep, it is a bit wobbly, but it was wobbly like that before. I wonder if its 494 has been damaged. There's nothing over this side. So we've got nothing on this bank. So we're missing the drive on this bank. So that is these 4 here. These 2 here. So let's see what's going on here. So the drive, yeah, that's these ones here. So let's turn that on again. So yeah, I've got nothing over here. So let's see, I've got no output there. Do we have input? No. Huh, okay. Could be because I've bridged all those connections there, thinking that was going to work. So maybe if I unbridge those. Right, let's see now. Okay, so still no drive. So I don't think that's making a connection to the top of the board. So I just need to go ahead and probably solder top board onto that. Yeah, something doesn't look good in there. So let me just very quickly try and figure out what's not happy about this area. Okay, no drive here either. And that could be, actually, I think that's because of the missing Zener. Yeah, the Zener diode is, that's the one with the missing Zener diode. Although there doesn't seem to be anything on the Zener diode either. There's no drive on the Zener diode pads. Okay, well, I'm going to have a look at that in a bit and work out why we haven't got any drive there. If need be, I'll jump over some connections from the other pads, because these are pretty much all paralleled anyway. So I should have the drive wave on here. They're both connected anyway. These need to be both connected, so I can do that and resolder. Yeah, the drive needs to be the same on these two, Okay, so there's something I need to quickly look at in there, work out why that was not getting sent any drive. But bear with me for, I would say, an hour. I'm going to go get some food, and then we shall continue with this once I have eaten. So it's not goodbye, it is see you shortly.